Python machine learning, and this is about scale. Scale features. So we'll be discussing about scale features of Python. Now, as an introduction, so when your data has different values and even different measurement units, it can be difficult to compare them. What is kilograms compared to meters, or altitude compared to time? The answer to this problem is scaling. When we scale data into new values that are easier to compare. Take a look at the table below. It is the same data set that we use in the multiple regression chapter or video, but this time the volume column contains values in liters instead of cubic meters, so 1.0 instead of 1000. The file is meant for testing purposes only, and again it can be downloaded in this link. So I'll be providing this link in our video. So we have here again the car, the model, the volume, so this time around in kilograms or in cubic meters, and the weight in kilograms, and we have here the CO2 emission. So this is now in liters rather than cubic meters, cubic centimeter. It can be difficult to compare the volume 1.0 with the weight 790 because of the discrepancy, or the values are far from each other. But if we scale them both into comparable values, we can easily see how much one value is compared to the other. There are different methods for scaling data. In this tutorial, we'll use the method called standardization. And the standardization method uses this formula. Z is equal to X minus U divided by S, where Z is the new value, X is the original value, U is the mean, and S is the standard deviation. So if you take the weight column for the data set above, the first value is 790 and the scaled value will be 790. So this is the first value. So we have to get the mean and we have to get the standard deviation. So we have 790 minus the mean divided by the standard deviation is equal to negative 2.1. For the volume, the same. So this volume, we have to get the mean and the standard deviation. So if you take the volume column from the data set above, the first value is 1.0 minus the mean divided by the standard deviation is equal to negative 1.59. So now if you compare negative 2.1 with 1.59, instead of comparing 790 with 1.0, that's easier to compare. You don't have to do this manually, since the Python sklearn module has a method called standard scaler, which returns a scalar object with methods for transforming datasets. So here's an example of using the standard scaler. So we have to import pandas for us to be able to read the CSV file, sklearn to import a linear model, sklearn pre-processing, import standard scaler. So we have here now our scale is equal to standard scaler. So we have this object. And then df, so we have read the data file. We have our list. So we have to convert this list, or we have to scale this list. That's why scale.fit transform x, scaled x. So using this method and using this list and using this object, we have now created a scaled value or scaled equivalent of this in scaled x. So if you print scaled x, so these are now the values. And so if we use the same program a while ago, so import pandas from sklearn, import linear model from sklearn, that pre-processing, import standard scaler, scale equals standard scaler. So this is our scale object. We read the data file, then we have here now or our data frame, and then we have a list of weight and volume placed in x, y equals to dfco2. Then we have scaled x, scaled fit transform x. So that's what we're going to use now. So regression equals linear model, linear regression. So that's our regression object. We have to fit data or place data to that one. using our x and y value, but this time around, instead of using x, we use scaled x. So we have now regression fit, and with that we have now the data here, so we can predict. So scaled equals scale transform. So we have this value, so we have to transform this. We have to scale this also. So 2301.3. So scale transform 2301.3. So we have here this value. Then predict CO2 regression that predict. So scaled 0. So because we have to scale this also. And then print predict CO2. So we have 107.2087328. So that's the use of scaling. Thank you very much for viewing this video.